Unity's UI Toolkit has always felt like a bit of a mystery to many of us. It promises better performance and flexibility across different platforms, but how does it actually work? Whether you're a beginner or a pro, in this video will break down everything you need to know about the UI Toolkit, so let's get into it. Before we dive into Unity and start getting our hands dirty, it's important to first understand a key concept of UI Toolkit. Basically, it's made up of three main parts: UXML, USS, and C#. UXML acts as the foundation. Think of it like the structure or layout of your user interface. It tells Unity where each UI element goes and how everything is organized. Next, we have USS, which stands for Unity Style Sheets. This is where we style our UI elements, things like colors, fonts, spacing, etc. One really cool thing about USS is that you can create a style once and reuse it across multiple elements. So for example, if you make a button style, you can just apply that same style to every button in your scene with a simple drag and drop. Finally, we bring in C# to add functionality. This is where we write the logic, like what happens when a button is clicked, or how the UI responds to user interactions. This video is sponsored by me. If you found it helpful and want to support what I do, consider buying me a coffee. The link is in the description. Every bit of support helps me keep creating these tutorials and sharing what I learned with you. Alright, now let's move on to actually creating a UI using the UI Toolkit. First, go into your project window in Unity and right-click where you want to create your UI file. Then go to Create UI Toolkit and finally click on UI Document. This will create one new file. Name it whatever you like. And just like that, we have successfully created our first UXML file. Now to edit this file, double-click on it to open it in UI Builder. The UI Builder interface is divided into different panels or different sections, such as the Style Sheet, Hierarchy, Library, Viewport, and Inspector. Each of these has its own purpose. Now let's focus on the Library panel. This is where you'll find all the UI elements you can use in your design. Things like buttons, labels, text fields, scroll views, and other visual components are all available here. Basically, the library is like your toolbox. If you want to add a button to your interface, for example, you can just find it in the library and drag and drop it on the hierarchy. And in Viewport, you can see your UI. Now, let's take things a bit further. In the UI Builder, go to the Library panel, and from there, drag a visual element into the Hierarchy panel. Think of this visual element as a container. It will hold other UI elements inside it. Next, drag and drop 3 to 4 buttons inside this visual element. You'll notice something interesting: all the buttons stack on top of each other vertically. You might wonder, why are they being arranged this way automatically? That's because of something called Flexbox, which is the default layout system used in UI Toolkit. It controls how child elements like the buttons are arranged inside a parent container like the visual element. Click on the visual element and in the Inspector panel, look for the Flexbox settings. You'll see that by default, the direction is set to column. This means elements are arranged from top to bottom. Now try changing the direction. If you change it to row, the buttons will be arranged horizontally, side by side. If you choose column reverse, the buttons will still be in a column, but in reverse order from bottom to top. And if you choose row reverse, they'll be arranged in a horizontal line, but from right to left. Alright, let's dive into Flexbox. This can be a bit confusing at first, but don't worry. Once you get the hang of it, it becomes much easier. Think of Flexbox as a container that holds child elements, things like buttons or any other UI components. The key to understanding Flexbox is knowing how it uses two main axes: the main axis and the cross axis. Here's how it works. If you set the flex direction to column, the main axis becomes vertical and the cross axis is horizontal. If you set the direction to row, the main axis is horizontal and the cross axis becomes vertical. So the main and cross axis switch depending on the direction you choose, kind of like the moving stairs in Harry Potter. Now, why is this important? Because the grow, shrink, and basis properties all behave based on the main axis. Let's visualize this. Suppose we give our visual elements a background color so we can clearly see their size and position. You'll notice that the element stretches and takes up all the space inside the container. That's because its flex grow property is set to 1, which means take all the available space in the main axis if the parent container has space. If we set flex grow to 0, the element only takes up as much space as its content needs. So if we set the grow property of button to 1, the button will take all the available space in main axis. Now, here's an interesting observation. If you set a button's flex grow to 0, but it's still taking up a lot of space horizontally, you might wonder, why? Well, it's because of the cross-axis behavior. Let's break it down. If the parent container has flex direction, column, the main axis is vertical, and the cross-axis is horizontal. So the button will stretch horizontally to fill the cross-axis, even if grow is 0. When you change the direction to row, now the main axis is horizontal and the cross-axis is vertical. The button stretches vertically this time, unless you override that behavior by setting the size manually. So if you go under the Size tab and change it now, the button will not stretch on this cross-axis. So remember, grow, shrink, and basis all operate along the main axis. But elements may still stretch across the cross-axis by default, unless you set the cross-axis size manually. Now, let's talk about flex shrink. Shrink comes into play when there isn't enough space in the container. It tells the browser, how much should this element shrink compared to others? Let's say you have 3 buttons inside a container, and their total width is more than the container can hold. If all buttons have flex shrink 1, they'll all shrink equally to make everything fit. If one button has flex shrink 0, it won't shrink at all. It will keep its original size, and the others will shrink more to compensate. Alright, now let's break down flex basis in action. First, let's create a visual element and set the flex grow to 0. Now, what do you see? Nothing. The inner element disappears, or more accurately, it shrinks to 0. That's because its grow is set to 0, so it doesn't expand. And since there's no content inside, it doesn't take up any space on its own. So what if you still want it to have some size, even when it has no children or content? That's where flex basis comes in. Now let's set flex basis to something like 100 pixels. Now the element will take up exactly 100 pixels along the main axis, regardless of whether it has any content inside. Now when you again set your grow to 1, it will take the remaining space, so flex basis defines the initial size of an element before grow or shrink are applied. You can think of it as the starting point where the ideal size the element wants to be. Once you understand main axis and cross axis, alignment in Flexbox becomes really simple. For example, when I hover over align items in a UI tool or inspector, I get a tooltip that says aligns items along the cross axis. Now, in my case, I've set the flex direction to column. That means the main axis is vertical, the cross axis is horizontal, so when I use align items, it arranges the child elements horizontally along the cross axis. Similarly, justify content aligns elements along the main axis, so in this case, vertically. These alignment properties are super easy to use once you understand how the axes work. Now let's say you have a situation where you don't want Flexbox behavior. For example, you have a button and a small red dot, and you want to place that red dot on top of the button, like a notification badge. But by default, the button and the red dot are just laid out one after the other, button on top, dot below, because of the normal Flexbox flow. To break out of that layout and place the red dot exactly where you want, you can use absolute positioning. To do that, click on the red dot in your inspector, then go to the position setting and change it from relative to absolute. Now the red dot won't follow Flexbox rules anymore. It's no longer part of the normal flow, and you can position it wherever you want. For example, in one of my UIs, when I equip an item, a pop-up message shows up. Same for when a gold purchase fails, a notification appears on top. That's all done using absolute positioning. One more thing I forgot to mention earlier, if you're building a UI for multiple screen resolutions, avoid using fixed pixels values for layout. Instead, use percentages. This way, your UIs adapt better to different screen sizes, especially on mobile devices or when resizing the browser window. Alright, let's say I've designed a UI panel, and now I want to use it during runtime in my game. So how do we do that? In the Unity editor, right-click in the hierarchy. Go to UI Toolkit, then UI Document. This will create a game object in your scene with a UI document component attached. Take your UXML file, which is the layout you designed. Drag and drop it into the visual tree asset slot in the UI document component. Now, your UI layout is connected to the scene. Now, to ensure your UI scales properly on different screen sizes, click on the panel settings asset. In the inspector, find the option called Scale Mode. Set it to scale with screen size. Then set your reference resolution. This tells Unity to scale your UI based on the resolution, which makes it more responsive and clean across different devices or screen sizes. After doing all this, you might not see anything in the scene view. Don't worry, that's normal. To actually see your UI in action, Switch to the Game tab. You'll now see your UI panel displayed as part of the game screen. You may notice that the UI looks quite different in the game view compared to the UI builder. This is usually due to a resolution mismatch. For example, if you set the reference resolution in your panel settings to 1920 by 1080, but your game view is currently set to 726 by 408, the scaling will appear off. It's an easy fix. In the game view, change the aspect ratio or resolution to full HD to match your reference resolution. In the UI builder, click on the Match Game View button to sync the preview window with your game view resolution. Once you do that, your UI will look consistent across both the UI builder and the game view, and you can adjust your layout accordingly. Now let's create some styling to make our UIs look awesome. To start, create a new folder in your Unity project and name it USS. Then, open the UI builder, go to the Style Sheet section and create a new style sheet. Just like that, you've successfully added a style sheet to your project, though it's currently empty. Now, back in the UI builder, add the newly created style sheet to the Style Sheets panel so it can be used for styling your elements. You can apply styles to UI elements in three main ways: by type, by ID, and by class. To style by type, for example, to style all buttons, just type button in the style sheet without any dot or hashtag. This will apply the style to all buttons in the hierarchy. Try changing the width, height, text size, and border radius. You'll see all buttons update accordingly. If you want to target a specific button instead, delete the general button style, assign a unique name like My Button to your button in the hierarchy, then in the style sheet, create a new rule using hashtag MyButton. Any styles you add will now apply only to that button. Lastly, to use class-based styling, delete the current style and create a new one using a dot, like .CustomButton. You can then drag and drop this class onto any buttons you want to style. The class name will appear under the style class list for those buttons. These are the three main ways to style your UI elements in Unity's UI Toolkit. You can also override styles in UI Toolkit. For example, if you've added a style that gives all buttons some margin to create space between them, but notice that some buttons like those in the top panel are getting pushed out, you can fix this by selecting the specific button and setting its margin to 0. This overrides the margin defined in the main style sheet. So basically, you can override any style property and it will no longer follow the global style, but instead use its own. If you've added a style to an element and it's not working as expected, first check whether another style is overriding it and unset that property if needed. Now let's add this cool hover effect. Create a new style and add hover after its name. Then go to the inspector and find the transform panel. Increase the scale to something like 1.5. Now click on preview to see hover effect in action. Now, when you hover over the element, you can see the button is scaling. You can also add rotation and change its color in the hover state, and it's that simple to add hover effects to your buttons or UI elements. Now to make the transition smooth instead of an instant change, go to the hover effect settings, find the transition animation section, set the duration to 0.5 and choose an easing mode like ease in out sign. This makes the animation smoothly interpolate instead of snapping. Now let's talk about how we can change the style of other visual elements like sliders or any others, because it's not that straightforward. For example, if you drag a slider from the library into the hierarchy, you might notice that you are not able to change the slider's handle or fill area directly, because the options are grayed out and you cannot manipulate its style. To fix this, click on the slider, then find its handle in the hierarchy. When you click on elements inside the slider, you'll see that elements in the viewport are getting highlighted. After finding the handle, click on Add Selector. This adds a new selector to your style sheet. You will see it uses nested selectors. If you look at the name of the selector, you'll notice that it starts from visual element, then goes through Unity slider, and finally reaches the handle. Currently, it's also including the parent element. In our case, the parent is named visual element, so you can remove that by renaming it. Now, change the styling to make the handle round by adjusting the border radius and applying some scaling. All sliders will now have rounded handles. For example, if you add another slider to the hierarchy, you'll notice it also has a rounded handle. However, if you only want a specific slider to be affected, use a custom class name instead of targeting the general slider element. Add a class name like MySlider in place of the default slider type and apply it to the desired visual element. Now, only that specific slider will have the style change. Alright, let me explain how you can access UI elements in your script so you can add behavior, like what should happen when a button is clicked. First, create a new folder in your project directory and name it scripts. Inside this folder, create a new C# script and name it anything you like. To access UI elements like buttons, you need to reference the UI document component, which holds the root visual element. This is the base container that includes all your UI elements. Open your script and at the top, declare a serialized field variable of type UI document. Then create another variable of type visual element and name it root. This root variable will store your root visual element so you can access your UI hierarchy from it. In the start method of your script, you need to initialize the root variable by assigning it the root visual element from your UI document. Once you have the root set up, you can get any UI element by its name. But first, make sure your UI elements like buttons are properly named in the UI builder. So let's rename our buttons in the UI builder. Now let's grab the play button. To do that, you can use this method. So basically, you can get any visual element using this method. Now, suppose you have two quit buttons in your UI, and they both share the same name. By default, the first query method will only return the first one. If you want to access both buttons, use this query method to get all the buttons. This returns a list of all buttons with the name quit button, so you can loop through them and perform actions like assigning click events. Just remember, use the first query method when you want a single element, and use the second query method when you want a group of elements. In Unity's UI Toolkit, every visual element, like buttons, labels, or panels, can respond to user interactions called events, such as clicks, pointer movements, or key presses. For this explanation, let's focus on the click event, though other events, like the value changed event, are useful for tracking changes in elements like sliders. You can learn more about different events via the link in the description. To make a button respond to a click, you register a method to its click event. For example, when a user clicks the play button, the registered method runs. To see this in action, first assign your script to the UI document object in Unity and link UI document. Then, when you hit play in the editor and click the play button, you'll see a message printed in the console confirming the click event worked. Now, let's talk about hiding or showing panels, which is a fun way to control your UI. In the UI Builder, under the Display tab, you can toggle a panel's visibility using buttons to show or hide it. In code, you can do the same by accessing a panel, like a top panel, and setting its style.display property. Use displaystyle.flex to show the panel or displaystyle.none to hide it. I've used this technique in my project to toggle different panels on and off. Here's a challenge for you. When the play button is clicked, write a code to hide or show the top panel. This will test your understanding of events and panel visibility. So pause this video and give it a try. One last tip. When registering a callback for an event, you can pass a single argument to the method, but only one variable is allowed, just like this. Okay, so let's talk about a really helpful feature in Unity's UI Toolkit called data binding. It can save you a lot of time and effort when building user interfaces. To see why it's useful, let's look at how things used to work with the older method, which is model view presenter approach. Say you're making a game and you want to show the player's health on the screen using a label. Every time the player takes damage, you have to update the health value in your code and then separately write code to update the label so it shows the new value. That's not too bad for small things, but if other parts of the UI also need to change based on it, you'd have to repeat that kind of update code a lot, like for every UI element. It gets messy quickly. You're basically writing glue code all over the place just to keep the data and UI in sync, which increases the chances of bugs and makes your project harder to manage. Now, with the new UI Toolkit approach, which is based on the model view model pattern, Unity gives us something way better: data binding. With data binding, you connect your UI elements, like labels, directly to your game data. So when the data changes, the UI updates automatically. No need to manually write update code for UI. It's like setting up a live connection between your game's data and the UI. This means less code, a cleaner structure, and an easier time growing your project without it turning into a mess. Okay, now let's see how we can use data binding. First, we'll look at how to do it using a scriptable object, and then we'll see how to do it at runtime using a script. So I have this simple health UI, and I want to update the health. Let's create a scriptable object to handle that. Right-click in the project window and create a new scriptable object script. In that script, create a public variable like health and assign it a value of 100. Now, create an instance of that scriptable object in your project. Then, open the UI Builder. At the top visual element, you'll see an option to assign a scriptable object. assign the one you just created. All the child elements will now have access to this scriptable object. Next, find the label where you want to display the health, left-click on the text field and add a binding. You'll see that our assigned scriptable object is correctly referenced here. Now, in the data source path, write the exact name of the variable defined in the scriptable object. In this case, it's health. Now, set the binding mode to target and save the binding. You'll notice that you can no longer edit the text directly in the UI builder. That's because it's now bound to the data. When you change the value of the scriptable object, the UI text will automatically update. If you set the binding mode to source, it works the other way around. Changing the UI text will update the data source instead. I think the other binding modes are pretty self-explanatory. Let's move on. Now let's say you don't want to use a scriptable object and prefer using a regular class for your data. You can do that easily. First, remove the scriptable object reference from the UI builder. Then, open your script and create a new class. Name it player health, and inside it, create an int variable called health. In the start method, create an instance of the player health class. Then get the root visual element and set root.dataSource to your newly created object, just like you would with a scriptable object. This object is now accessible to all children of the visual element. In the update method, increment the health variable whenever the spacebar is pressed. Open the UI builder, select the label, and bind it to the health variable, just like before. When you play the game and press the spacebar, the health value increases. Now let's say you want to change the background color based on an integer value. For example, when health is 0, change the background to red, and so on. In this case, you can just bind the value directly. You need to use converters. Converters are useful when the types don't match, for instance, using an int to control a color. Here's how to do that. First, create a new script and name it global converters. Then copy and paste the converter code into your script. You'll need to register the converters like this. It's a generic method where the first type is the source, like int, and the second type is what you want to convert to, in our case, style color. Now, how do you know that you need to return style color? It's easy. When you add a binding, look at the top corner of the UI Builder panel to see what type it's expecting. In the converter, use a switch statement to return the appropriate color based on the value. Next, make the class serializable so it can be edited in the inspector. Open the UI Builder again, bind the color property to the root visual element, and assign the correct variable name. In the advanced settings, find the converter option and assign your converter there. Now, when you play the game and change the health value, you'll see your converter in action. The background color updates as expected. So that's a brief introduction to Unity's UI Toolkit. Of course, there are still some drawbacks. For example, you cannot add custom shaders to UI elements, complex animations aren't supported yet, and it can be tricky to use in world space. Well, let me know what you think about UI Toolkit. Thanks for watching, and I'll see you in the next one.